one important feature of inverse functions that we haven't really talked about is the fact that they are, well, functions. Here, for example, are the functions we were working with in the last quiz. We started out with the equation y equals 4x and found that its inverse is y equals x over 4. Of course, the original equation is a function, but we can tell that its inverse is 2. It passes the vertical line test. We saw that y equals 4 over x is its own inverse. It passes the vertical line test too. Another fun fact about this is you can tell it's its own inverse because the function itself is symmetric across the line y equals x. Now, if we had a function and we went through the process of finding its inverse, but the resulting equation did not graph a function, then the original function would not have an inverse at all. I know that sounds kind of complicated and that would involve a lot of steps. So luckily, there's an easier way to tell whether or not a function will have an inverse. It involves graphing. Now, I just said that we can figure out if a graph represents a function by using the vertical line test. And we also know that in order to graph the inverse of a function, we need to reflect it in the line y equals x. So what if we decided to reflect a vertical line in the line y equals x? Here I've graphed a random vertical line. I happen to pick x equals 4. And this dotted black line is the line y equals x. What is the reflection of x equals 4 in the line y equals x? Please write the equation of this new line in this box.